So let's continue from where we were. So we had seen u being equivalent to x plus 3, and then we let v to be equivalent to x squared plus 4. So now, then we say that from u equals to x plus 3, we need to find the derivative of u, and that is du dx, given as the derivative of x plus the derivative of 3. And we said when you differentiate x any value with a power of 1, we get a constant of 1. And then if we differentiate 3, which is a constant, we get a 0. So we'll find that the derivative of u, our du dx, would be equivalent to 1. Would be equivalent to 1. So back to the issue that we say that whenever we differentiate a value with a single power, we get a constant. This is how it comes about. Supposing we have our x being with the power of 1, x power 1. Supposing we have u equaling to x power 1. And you're interested in finding the derivative. So meaning our derivative du dx would be one, which is the power, times x power 1, then reduce the power by 1. So meaning we end up with du dx equals to x power 0. Minus 1 results to 0. But any number to the power, the number to power 0 is equal to 1. So this is the principle we're applying. So any number to power 0 is always equal to 1. That is why that means that x power 0, that means that x power 0 is equal to 1. From the above rule principle that we've said, any number to the power of 0 is equal to 1. So meaning x power 0 is equal to 1, as we can observe. So that is why when we differentiate u equaling to x plus 1, we get a 1. So that's why we have our derivative as du dx being equal to 1, du dx being equal to 1. So that is u given as x plus 3 being differentiated to obtain a 1. So now if we continue from v, remember v is equal to x power 2 plus 4. So we also need to find the derivative of v by differentiating v with respect to x. So meaning dv dx would be, if we differentiate x squared, we get 2x. I hope Still remembering where we came from. If you differentiate x squared, you get 2x. That is the power of 2 multiplied by x, you get 2x. So if we reduce the power of 2 by 1, we get 1. The side which can be silent. So if we differentiate x squared, we get 2x. And if we differentiate 4, which is a constant, we get a 0. So meaning our dvdx is equal to 2x. In other words, if we differentiate v equals to x squared plus 4, we get dvdx equivalent to 2x. So meaning we now have u, we have v, we have du dx, we have dv dx as well. So we can find the y dx with the template that we had already under the product rule. So how are we going to get the dy dx? This is going to be obtained as follows. Dy dx equals to v du dx, which v we know and which du dx we also know because we've already derived them. So dy dx would be v, which is x squared plus 4, which is x squared plus 4, v, which is x squared plus 4, times du dx. Our du dx is 1. We differentiated u to obtain a du dx of 1. So times 1 plus u. Our u is x plus 3. Our u is x plus 3. Our u is x plus 3. Times dv dx. Our dv dx is 2x, as you can observe. So now we are going to open brackets by multiplying the respective values as below. So 1 times x squared, we get x squared. Get x squared. We get x squared plus 1 times 4. We are trying to open brackets. The values which are outside brackets, multiply every variable in brackets, and that's what we are doing. We began by multiplying this 1 by x squared. We got x squared. Now we are multiplying 1 by 4, and we are getting 4 plus 2x times x, we get 2x squared. We get 2x squared plus 2x times 3, we get 6x. So we can collect like terms. Collect the like terms. So we bring the square powers together. X squared plus 2x squared plus 6x plus 4, meaning our derivative would result in 2. dy dx would be x squared plus 2x squared, we get 3x squared get 3x squared plus 6x plus 4, and this would be the derivative of the expression given y equals x plus 3 into x squared plus 4. When we differentiate this using the product rule, we obtain this. So that is the derivative under the product rule. So we can continue with our rules. So go to the next rule. So our next rule is where the function is a quotient. Where the function is a quotient. So how do we find the derivative if a function is a quotient? So we find that a quotient is a result of division. So whenever we differentiate, whenever we divide expressions, the result we get is called a quotient. So finding or differentiating an expression using the quotient rule, or we differentiate a fraction using the quotient rule, as we are going to observe. So here we are told that if u represents a function x, which is the numerator, if u represents the function x, which is the numerator, and v represents a function y, which is the denominator, where y equals to u over v, then the derivative is obtained using a quotient rule. So in this case, our du dx would be given by the quotient rule, which rule is stated as follows. So when using the quotient rule, y dx is equal to v du dx minus, this time is a minus, u dv dx all over v squared, all over v squared. So whenever we are differentiating a fraction of expressions, we use the quotient rule to find the derivative. So we have an example here. Example says differentiate example says differentiate y equals x squared minus 1 over x squared plus 1, x squared minus 1 over x squared plus 1. So the question is find dy dx, find dy dx, meaning you have to differentiate the expression of y to obtain the derivative of dy dx. So here we go. So for us to find the dy dx, we need to let, as before, we let one expression be u and let the other one also be v. For example, let the numerator be our u and the denominator be v, as follows. So meaning our u would be x squared, our u would be x squared minus 1, and v would be x squared plus 1. So now we have u, we have v. Remember, we are using the above rule, the quotient rule, which is in green as I'm highlighting it. Now we need to find du dx and we need to find dv dx. We need to find du dx, we need to find dv dx. So now from u equaling x squared minus 1, du dx would be obtained by differentiating x squared minus 1 with respect to x. So our our du dx would be equaling to, if you differentiate x squared as we've been following, if you differentiate x squared we get 2x minus 1. If we differentiate 1, which is a constant, we get a 0. So meaning our du dx would be, equal to 2x. In other words, when you differentiate x squared minus 1, we get 2x, as you can observe. Then from v equals to x plus 1, we can also differentiate it to find the v dx. Can also differentiate it to find the v dx. So our dv dx would be obtained by differentiating that expression x squared plus 1. So if we differentiate x squared, we get 2x. Then if we differentiate 1, which is positive and a constant, if we differentiate the 1, we get a 0. In other words, our derivative of the v dx would be equivalent to the v dx would be equivalent to 2x. So the v dx is equivalent to 2x. So the v dx is 2x, the u dx is 2x, u is x squared minus 1, v is x squared plus 1. So now we can go ahead and substitute into the quotient rule of dy dx. A template to obtain the dy dx. So our dy dx would be v, which is x squared x squared plus 1 times du dx. Our du dx is 2x minus u, which is x squared minus 1 times dv dx. Our dv dx is 2x all over v squared. Our v squared will multiply x plus 1 to square x plus 1, because our v is x squared plus 1. So right, let's continue. So now we are going to open up brackets. We're going to open up brackets as follows.